In the broader scope of the AZ-104 certification, understanding how to map a custom DNS name to an Azure App Service builds on skills acquired when working with Azure Resource Manager templates, bicep files, and other compute-related configurations. By this point, learners have explored virtual machines, container deployments, and app service fundamentals. Mapping a custom domain is an essential step in establishing a professional and user-friendly web presence. It involves registering or owning a domain name, configuring DNS zones, and ensuring that your Azure App Service is reachable under a personalized URL. Unlike the default name provided by Azure, which includes an Azure Websites.net subdomain, a custom DNS name elevates the presentation and branding of your application. Within this context, the process involves creating relevant DNS records, such as name or records, and verifying domain ownership so that traffic seamlessly directs to the Azure-hosted application. Domain Name System, DNS, is the foundational service that translates human-readable domain names into IP addresses. This system ensures that when users type a familiar URL, the request is accurately routed to the appropriate server. DNS consists of multiple record types that specify how a domain name is resolved, such as records that map names to IP addresses or name records that map an alias to another name. In Azure environments, these DNS concepts remain critical for ensuring your app service is highly available and easily accessible. When mapping a custom domain, DNS configuration determines the path of client network requests, tying a newly created or existing domain to the Azure resources. Careful management of DNS records reduces misconfiguration and prevents downtime that could arise from user requests being misrouted. By mastering these DNS fundamentals, administrators can fully leverage Azure services and streamline the deployment process. Azure App Service is a managed platform for hosting web applications, REST APIs, and backend services. By abstracting away typical infrastructure tasks, like server provisioning and patching, App Service allows administrators to focus on application development and deployment. This service simplifies scalability, deployment slots, and integration with continuous deployment pipelines. Because it is highly available and globally distributed, organizations utilize it to host both production and test environments with relative ease. As part of the course, learners examine how to create app services, configure them through ARM templates or bicep files, and optimize performance with scaling features. When it comes to custom domains, the app service must match organizational branding, enhance discoverability, and present a professional image to end users. By integrating custom DNS names, each application can be tailored to align with specific naming requirements while leveraging the robust features that Azure provides. Before mapping a custom DNS name to Azure App Service, a valid domain must be obtained from a registrar. Registrars such as GoDaddy, Namecheap, or Azure itself provide domain names under top-level domains like .com or .net. During registration, the domain owner must specify relevant contact details and often can manage DNS settings directly within the registrar's administrative panel. Alternatively, domain owners could host DNS with a separate provider or with Azure DNS. Regardless of which approach is taken, obtaining a domain is a fundamental prerequisite. This domain acts as a user-friendly endpoint that directs visitors to the desired application. By partnering with a registrar that offers robust DNS management features, owners can simplify the process of adding or modifying DNS records and ensure a seamless transition from a generic Azure Websites.net domain to a brand-specific custom name. In advanced scenarios, domain reselling and specialized domain suffixes might be considered. To effectively route traffic to an Azure App Service instance, administrators must create particular DNS records. Common record types include address records, which directly map a host name to an IP address, and name, canonical name, records, which provide an alias to another domain. Azure App Service frequently relies on name records to ensure changes in the underlying IP do not break domain mapping. For custom domain configurations, a specific record type known as TXT might also be used to verify domain ownership. DNS best practices suggest using name for flexible aliasing. However, when traffic routing and SSL certificate creation require direct IP addresses, an A record may be preferable. Understanding these record types, their intended purposes, and how they interact with Azure's platform helps ensure that the deployed applications remain accessible. Additionally, awareness of TTL, time to live, values enables timely updates when changes occur. Before assigning a custom domain to an Azure App Service, it is crucial to verify that your current app service plan tier supports custom domains. Generally, basic and higher tiers allow custom domain mapping, while the free tier does not. You also need domain access to manage DNS records and delegations. Additionally, application settings, including the domain verification ID, might need to be cross-referenced to ensure that the domain is pointed to the appropriate Azure resource. Some organizations use a consolidated DNS management approach, so verifying where the records will be stored, whether on the registrar's panel or Azure DNS, provides clarity. Another important detail is that certain domain-level security features, such as DNSSEC, might require extra steps, though it is not always necessary for typical app service mappings. Proper planning, ensuring the correct plan tier, and verifying domain readiness all streamline the mapping workflow. Azure makes it straightforward to add a custom domain to your app service through the Azure Portal or Azure CLI. In the Azure Portal, you select the app service, navigate to the Custom Domains blade, and choose the Add Custom Domain option. From there, you're prompted to enter your hostname, such as www.mycustomdomain.com, and to verify domain ownership. The platform provides the instructions needed to create or update your DNS records, typically involving a TXT record or a name entry. Once these new DNS records propagate, Azure can confirm that you own the domain. This confirmation is essential before the custom domain is fully linked to your web application. If using the Azure CLI, you would rely on commands like AZ-web-app-config hostname add, specifying the resource group, web app name, and custom domain. Regardless of the interface, the process centers around verifying domain ownership and linking the domain to your app service. When instructing the DNS system about a new mapping, Azure must confirm you own or control the domain in question. By requiring domain ownership proof, Azure protects application owners from unauthorized usage of existing domains they do not own. Typically, this confirmation involves creating a TXT record in the DNS zone that matches a code generated by Azure. The code is unique to your subscription and domain combination and remains valid for the verification process. Once you complete the verification by placing the code in the TXT record, Azure queries the domain's DNS, identifies the record, and proceeds to finalize the mapping. These steps ensure a secure and validated approach to domain mapping. This process also informs best practices in domain security, protecting organizations from domain spoofing threats. Once verified, subsequent modifications, like adjusting endpoints or adding subdomains, become more streamlined. A name record, often referred to as an alias record, maps a host name to another domain name instead of an IP address. In the context of Azure App Service, using a name is popular because it simplifies future maintenance. If Azure changes the IP address of your app service, the name record remains valid, as it points to the canonical Azure Websites.net address. To set up a name with a custom domain registrar, you navigate to your DNS management area and create a record specifying the hostname, such as www. Then, point it to the default domain for your app service, for instance contoso.azurewebsites.net. This approach particularly benefits production environments where administrators want minimal downtime during IP transitions or application migrations. Once the DNS changes propagate, the custom domain traffic flows directly to the designated app service, ensuring a stable and consistent user experience under the custom URL. In some scenarios, an A record might be used to map a domain or subdomain directly to the IP address of the Azure App Service. While this approach provides a direct connection, it is less flexible if Microsoft updates the underlying app service IP. Because the IP can change due to platform updates or rerouting, organizations must remain vigilant and adjust their records when that occurs. Additionally, When configuring a records for an app service, you might include an alias record, if the DNS provider supports it, to achieve the benefits of a canonical approach. Alternatively, you create a separate record to handle root domain mappings, ensuring that the bare domain, e.g., mycustomdomain.com, routes to the correct IP. Although it can be more direct, this method can introduce complexity when maintaining the domain over time. Nonetheless, for certain performance considerations, the A record route remains a valid method. Administrators often choose to host specific microservices or distinct application modules under subdomains, such as ap.mycustomdomain.com or blog.mycustomdomain.com. Setting up subdomains in Azure App Service follows the same principle as standard domain configurations. You create name or a records pointing the subdomain to the Azure assigned domain. This arrangement ensures that each subdomain can direct traffic to its respective environment. For larger organizations, subdomains can help structure content, segregate development environments, and apply specialized security controls. It is also possible to map subfolders within a single domain. However, subdomains remain popular for clarity and administrative separation. By leveraging multiple custom domain mappings under one Azure subscription, administrators can strengthen the brand identity of their services while also simplifying user navigation. Periodic checks to confirm DNS record propagation and certificate validity are advisable, particularly when subdomains proliferate in a multi-environment setup. Once the custom domain is mapped to the Azure App Service, organizations often secure the website or application using SSL/TLS certificates. Azure App Service supports free app service managed certificates for non-wildcard domains, which provide basic encryption for custom domains. To install these certificates, administrators can navigate to the TLS/SSL settings of the app service, select Create App Service Managed Certificate, and associate it with a verified domain. Alternatively, more sophisticated certificate solutions, like wildcard certificates or third-party signed certificates, can be uploaded for broader coverage. These certificates help maintain user trust by ensuring data transmitted between the client and server remains encrypted. In some compliance-heavy industries, advanced certificate management, such as automatic rotation and certificate pinning, might be required. Nonetheless, integrating SSL completes the custom domain experience, guaranteeing both branding consistency and the safety of traffic. Regular certificate expiration monitoring ensures there are no service interruptions. Administrators may encounter issues when mapping a custom domain to an Azure App Service. Common challenges include misdefined DNS records, delay in DNS propagation, or attempts to map a domain not yet verified. If the domain fails to resolve, verifying that the correct name or a record was added is crucial. Checking for spelling errors in the domain name or typos within record fields often results in connectivity problems. Propagation can take up to 48 hours, depending on DNS settings. Additionally, ensuring that the service plan tier supports custom domains cannot be overlooked. Another frequent pitfall involves improperly configured SSL certificates that might cause browser warnings or partial encryption indicators. Diagnostic tools such as Dig or NSLookup assist in confirming that the domain points correctly to the Azure resource. Azure logs and monitoring in the portal further clarify redirection or load balancer issues, providing actionable insights to restore normal application access. After successfully mapping your custom domain and verifying traffic flow, ongoing DNS maintenance becomes part of regular administrative tasks. As organizations evolve, domain name structures might change to support newly introduced services, additional regions, or rebranding efforts. Azure DNS or external DNS providers can manage these changes effectively, ensuring scaling and testing can occur without downtime. Strategies like traffic routing profiles in Azure Traffic Manager or Azure Front Door can further enhance performance and reliability across multiple geographies. Additionally, subdomain delegation can optimize DNS governance by allowing different departments or product lines to manage their unique namespaces independently. Beyond DNS, advanced security features, including web application firewalls, content delivery networks, and identity-based restrictions, can be integrated to strengthen the resilience of the deployed solutions. Through careful planning and consistent oversight, administrators leverage the combined potential of custom domains and Azure's platform to deliver robust, user-friendly digital experiences.